Sensors at Yellowstone pointed straight at a hot spring that had already exploded before. They were wrong. Just after 5 in the morning on June 13th, ground instruments in Biscuit Basin picked up a sharp burst of seismic and acoustic energy aimed at Black Diamond Pool. Hours later, geologists found the blast had torn through ground 30 to 60 meters away, in a spot never known to explode. This is the closest a hydrothermal explosion has ever detonated next to a live monitoring station, and the data it produced is now forcing scientists to rethink what is moving beneath Yellowstone's calm surface. Here's how that mismatch is even possible. Monitoring stations don't see an explosion directly. They catch shaking and a low-frequency rumble called infrasound, then triangulate a rough direction and distance from how those signals arrive at different sensors. It's an estimate, not a photograph. Usually it's close enough. This time, it pointed confidently at a spring with a known history, and the ground itself proved the estimate wrong by several dozen meters. By sunrise, the Firehole River running past the basin had turned a pale, milky gray. Park geologists arrived within hours and found 3 brand new vents cut into the ground, rocks scattered several feet from where they'd sat undisturbed for who knows how long, and a scar in the earth that simply had not existed the day before. Steam was still rising off the disturbed ground when the team walked in, the smell of sulfur thick in the cold morning air. Boardwalk railings nearby still standing exactly where they'd been the day before. As with past events like it, nobody appears to have been hurt. The U.S. Geological Survey's Yellowstone Volcano Observatory logged the event exactly as what it was, a hydrothermal explosion. Not lava, not magma breaking the surface. A pocket of shallow water, heated and pressurized underground, flashing instantly into steam and blasting its way out. Over years, minerals dissolved in that hot water crystallize into silica, sealing cracks below ground almost like scar tissue. Pressure builds behind the seal until something gives, sometimes slowly, as an ordinary geyser, and sometimes all at once, as an explosion. It's one of the real, documented hazards inside Yellowstone National Park, more common statistically than most visitors realize. June's broader numbers looked ordinary. 118 earthquakes logged across the park that month, the largest just a magnitude 2.4, barely a tremor. That's routine for Yellowstone. 2 months earlier, in April, a cluster of 16 small earthquakes rattled through the same general region over 2 days, part of 97 quakes that month alone. Swarms like that happen constantly here, evidence of fluid shifting and stress releasing along countless small faults underground, and on their own, they don't signal anything unusual. Ground deformation at the caldera and its north rim had shown no significant uplift or sinking since January. The alert level never moved off normal. The aviation code stayed green. On paper, Yellowstone looked quiet, which is exactly why the mismatch mattered. The obvious read was simple. Black Diamond Pool, which had already thrown rock and debris high enough to damage nearby boardwalks back in 2024, had gone off again. Same basin, same neighborhood, a known repeat offender with a documented history of doing exactly this. Except its own monitoring equipment barely blinked. The heat signal at Black Diamond Pool that morning was small, nowhere close to matching the force of an explosion that threw rock and carved fresh vents 30 meters away. The energy was real, the location it pointed to was not. So scientists tested it the way they'd test any suspect. Could the ground nearby simply be repressurizing on its own? An ordinary hot spring finally blowing its lid the way dozens do inside Yellowstone every few years? Possible, except the new vents opened in ground with zero explosion history. Nothing on record ever cracked there before. If this was routine venting, it chose a spot with no precedent at all. Next candidate, something deeper. In July of 2025, the north rim of the Yellowstone caldera had started to rise, a slow uplift a few miles from the basin. If fresh magma or gas were pushing up from underneath, an explosion nearby would make intuitive sense, but the timing argues against it. That uplift had already stopped months earlier, by mid-January 2026. Whatever caused it had gone quiet well before Biscuit Basin cracked open in June. A hydrothermal explosion is a shallow, water-driven event. It doesn't require fresh magma arriving underneath it, and nothing in the deformation record shows that happening here. That's when the real complication surfaces. For decades, most descriptions of Yellowstone treated what's underneath it almost like a single tank, one big reservoir of partly molten rock, fed by a plume of heat rising straight up from deep in the mantle. New research from 2025 and 2026 says that picture is wrong, or at least badly incomplete. Seismic and electromagnetic imaging published this year describe something closer to a segmented plumbing system, a shallow, gas-releasing magma cap sitting only around 3.8 kilometers down, and, deeper below that, multiple separate reservoirs instead of one continuous chamber. One study, using magnetotelluric surveys that measure how well underground rock conducts electricity, mapped at least 4 distinct pockets of melt scattered beneath the caldera, rather than a single reservoir. A separate modeling study goes further, arguing Yellowstone's melt may form from the shallow mantle itself, guided sideways by tectonic forces, rather than rising straight up through a classic mantle plume at all. That shallow cap, researchers found, appears to be releasing gas steadily rather than trapping it, which they describe as a sign of a stable system venting pressure on its own, not one building towards something bigger. Here's why that matters for a hole that opened in the wrong place. If heat and fluid move unevenly between separate pockets instead of one uniform chamber, pressure can build somewhere nobody was watching closely, while the well-known feature next door stays calm. A segmented system explains a surprise better than a single tank ever could. It also explains why headlines and agencies seem to disagree with each other. Some outlets described the explosion as proof that Yellowstone activity was ramping up. The Yellowstone Volcano Observatory described that same month as background level, alert status unchanged. Both statements are technically true because they're measuring different things. One dramatic, localized event is not the same as a shift in the long-running average. A single hole in the ground, however unnerving to stand near, does not move the needle on decades of monthly seismic counts. There's a second twist buried in the record books. This wasn't remotely the first hydrothermal explosion at Yellowstone, but the first one ever confirmed by modern seismic and infrasound instruments only happened in April of 2024 in nearby Norris Geyser Basin. That means part of what makes 2026 feel unprecedented isn't that the ground is doing something new. It's that scientists, for the first time in the park's recorded history, finally have sensors close enough and fast enough to catch these events as they happen. And the ground has done far more than this before. Along the north edge of Yellowstone Lake sits Mary Bay, the largest hydrothermal explosion crater ever documented anywhere on Earth. A scar roughly 2.5 kilometers across, more than 1.5 miles wide, blown out of the lake bed around 13,800 years ago. Researchers studying sediment cores believe it formed when a major earthquake triggered a sudden, dramatic drop in the lake's water level, instantly releasing pressure on the hydrothermal system underneath and setting off a chain of explosions in a very short span of time. A smaller companion, Elliott's Crater, formed roughly 8,000 years ago when a separate earthquake ruptured the mineral cap, sealing a different hydrothermal dome. None of this happens in a vacuum either. Elsewhere in the park that same season, Echenis Geyser, dormant for years, abruptly woke up and erupted dozens of times in a matter of weeks before falling quiet again. Basins like this shift constantly, on their own separate timelines, for their own separate reasons. A geyser waking up on one side of the park and an explosion tearing open on the other are not, by themselves, evidence of anything connected. That comparison should land hard, and it should. It means the ground beneath this park has, in the past, blown craters wide enough to swallow a small town. But scale and mechanism both matter here, and neither one supports treating June's event as a warning sign of something similar. Mary Bay's explosion needed an ice age lake, sudden catastrophic drainage, and a major regional earthquake acting together. Biscuit Basin's vents are a few meters across, driven by nothing more exotic than ordinary shallow water finding a new way to the surface. Same basic physics, radically different scale, and no shared trigger connecting the two. It's tempting to link every strange signal from this stretch of park into one bigger story. The paused uplift, the earthquake swarms, the new vents, all folded into a single narrative of a system waking up. The data argues against it. Hydrothermal explosions are driven by shallow water flashing to steam. Caldera uplift is driven by deeper fluid or magma-related pressure changes. Different mechanisms, different depths, no confirmed link tying one to the other in this case. Two unsettling events, same summer, same general area, probably not the same story. Meanwhile, the newest magma mapping research points attention somewhere else entirely. Of the separate reservoirs identified beneath the caldera, the largest and most magma-rich sites in the northeast section, nowhere near Biscuit Basin or Yellowstone Lake. If there's a part of Yellowstone's underground plumbing worth extra scrutiny going forward, based on current science, it is that quiet northeastern pocket, not the basin that just made headlines. So where does that leave the actual mystery? What's confirmed? A real hydrothermal explosion in a real and unexpected spot, correctly detected but initially misattributed to the wrong pool. What remains open? The exact precursor signals buried inside this data, the closest recording ever made of an explosion this size, this near a monitoring station, which scientists are still combing through for warning signs nobody has ever captured before. Nothing here proves Yellowstone is becoming more dangerous. The alert level hasn't changed. The long-term seismic average hasn't changed. What has changed is the resolution of the picture scientists are working from, and that picture now shows a more complicated, more compartmentalized system than the simple single-chamber sketch most people grew up picturing. Going forward, researchers are watching specific things, not vague unease. Renewed ground deformation at the North Rim would suggest the paused uplift cycle is starting again. New earthquake swarms migrating toward Biscuit Basin, rather than staying scattered, would suggest connected stress, rather than coincidence. Unusual gas or heat readings from that quiet northeastern reservoir would matter more than anything happening at the basin that already made news. None of that has been observed yet. All of it is exactly what would need to change before this story does. Go back to that first signal, the one that pointed the wrong way. It wasn't a false alarm. The instruments caught real energy in real time, exactly when it happened. They just couldn't yet tell researchers precisely where to look, and that gap, more than the explosion itself, is what Yellowstone scientists are now working to close. This July, a new seismic and infrasound station went in at Upper Geyser Basin, built to listen even closer than the last one did. It sits now over quiet ground that, a few weeks earlier and a few miles away, proved it could still surprise the people watching it most closely. If you've walked past Biscuit Basin recently or noticed anything unusual in that stretch of the park, the observatory would want to know what you saw.